For this problem, what we want to do is find the position of a particle, and we're given an equation for that position, which is s equals the square root of 3 plus 6t. We want to find the acceleration. Acceleration is the second derivative of position, and not only do we want to find acceleration, we want to find that acceleration after 1 second. So we're going to have to use the chain rule here on this guy, and what I'm going to do first is just rewrite this problem as 3 plus 6t to the 1/2 power. The reason I do that is because when I take a derivative, I need an exponent of some sort. I can't just take derivative of square root. So I rewrite square root as a 1/2 power. And then the function inside of my square root, I'm going to let be u. So u equals 3 plus 6t. And I'm going to just rewrite my equation now with the u where the 3 plus 6t is. That gives me s equals u to the 1/2 power. Okay? Now take my derivative. The derivative of u to the 1/2 power is 1/2 u and then 1/2 minus 1, which is negative 1/2. So 1/2 u to the negative 1/2 times du dx, and that's the chain rule part. We have to take the derivative of the u. We have to multiply by what that derivative is. So back over here to my red u, I need to find the derivative of that. Okay, and it's just 6. So substitute everything back in, substitute what I had for u, substitute what my derivative of u is into my equation. I get 1/2 times 3 plus 6t to the negative 1/2 times 6. That's my velocity. That's my velocity. I need to take the derivative of this again so that I can find acceleration. So again, I'm going to let u be equal to 3 plus 6t. All right. And I'm going to do negative 1/2 times 3, which is going to be negative 3/2. And then negative 1/2 minus 1 is negative 3/2. And then there's my u. And I take the derivative of him, and I multiply by that thing, which is 6. So when I clean all of this up, then I want to have negative 3/2 times 3 plus 6t to the negative 3/2 times 6. Clean all that up, and you end up with negative 9 times 3 plus 6t to the negative 3/2. This is my acceleration function. Okay. The last step is just to substitute in a 1 for all the t's. Well, there's only one t in there, and when I substitute that value in, I end up with negative 9 times 1 over the square root of 9 cubed, which is negative 9 over 27. That's a good answer. Okay. We could also reduce this to negative 1/3. And that's how you use the chain rule to find the second derivative, which is acceleration, at a specific value of t.